let's do this. Also, this is cool. What I do is I read out the entire story, and then in my edited content, I've been throwing a little snowfall animation on it, and I put music underneath it, and it's a perfect excuse because I wrote the snowfall animation using Rust with macro quad, so it's just a real simple algorithm, and then I wrote the music that's underneath it, so it's an easy way of shilling all this stuff that I've done. Day 7, Bridge Repair. The historians take you to a familiar rope bridge over a river in the middle of a jungle. The chief isn't on this side of the bridge, though. Maybe he's on the other side? Makes sense. Seems like there's only 2 possibilities there. When you go to cross the bridge, you notice a group of engineers trying to repair it. Apparently, it breaks pretty frequently. You won't be able to cross it until it's fixed. You ask how long it'll take. The engineers tell you that it only needs final calibrations, but some young elephants were playing nearby and stole all of the operators from their calibration equations. They stole the operators. They could finish the calibrations if only someone could determine which test values could possibly be produced by placing any combination of operators into their calibration equations, your puzzle input. For example, okay, and then we have this example here, number, colon, space, number, space, number, space, number. It looks like arbitrarily long list of numbers following the first colon. Okay. Each line represents a single equation. Oh, that's so nice, so I can process them individually. Okay, stop, I'm reading ahead. Each line represents a single equation. The test value appears before the colon on each line. It is your job to determine whether the remaining numbers can be combined with operators to produce the test value. Oh boy. Operators are always evaluated left to right, thank God, not according to precedence rules. Furthermore, numbers in the equations cannot be rearranged. Oh, this is so easy. Oh, this is... This is not as hard as it could have been, is what I meant to say. Glancing into the jungle, you can see elephants holding 2 different types of operator, add and multiply. Okay, so we have plus and star. Only 3 of the above equations can be made true by inserting operators. Oh, okay, so 10 and 19, yeah, if we put the multiply sign between them, we get 190. 81, 40, 27, I don't feel like doing this math in my head. Oh, they both equal that. Cool. So as long as one of them satisfies it, we're good. It seems like we only need to flip a flag on if we can find one that satisfies it. The engineers just need the total calibration result, which is the sum of the test values, those are the values on the left, from just the equations that could be possibly true. In the above example, the sum of the test values for the 3 equations listed is 3749. Oh, okay. Okay. So whichever ones could be made true, we need to add those all up. So we'll need our classic accumulator value that we've been carrying with us in most of our tests. Okay. Determine which equations could possibly be true. What is their total calibration result? Beautiful. All right, let's get started here. I will pop open the terminal and let's see what we got going on here. Also, for anyone curious, I said I would do this last time and I did. These are all now in a GitHub repository. You can see, go find my GitHub and then go to /advent-of-code. If you curl my website, as you know, my website, you can just curl it in your terminal and it looks terrible until I space out the terminal. There we go. If you scroll up here, I link to the source code. If you go to that, you'll get to my GitHub, so that's a pretty easy way to remember it. But yeah, so where are we? Let me remember where I left off. Okay, let me shrink this terminal a little bit so it doesn't get cut off by my face. Cool. We are there, so we should be in 2024. Make dir day 07, go into that directory, and cool. The first thing we will do is we'll get the example input.txt. I'm going to just copy and paste this over from the website. You can't see it, but trust that it is happening. There we go. There's our example input. While we're here, I'm going to get my real input too, and I'm going to stop sharing because this is supposed to be private and I'm not supposed to share this anywhere. It's probably fine to show it to stream, but I'm not going to risk it. Just trust that I'm copying and pasting my large set of input, and we will go back to the terminal. And we can see, I will show you where we are. We have 2 files, example input, which is what I took from the website, and we have real input, which is a lot more records. So that is what we have so far. Okay, so what we have to do here is we have to inject operators between these numbers and see if we can make them true. We have 2 different possible operators, and let's take this line for example. There's 2 numbers, we need 1 operator. There's 3 numbers. Oh, I'm not sharing my browser. I'm sorry. So we need to take these numbers and add operators to them. So right here, there's 2 numbers. We need 1 operator. There's 3 numbers, so we need 2 operators. There's 4 numbers down here, so this is going to need 3 operators. We will need n minus 1 operators. Okay, so we know how many operators we have, and we know the number of operators we'll need. What we can do is we can construct all possible arrangements of operators. So let's take this line, for example. The possible operators would be plus plus, plus star, star plus, star star. So we have to go through all possible permutations, combinations, one of the two. I always get them confused. Another way you could think of this is I think you could do, there's two possibilities in arbitrary length. I think you can do 2 raised to the power of the arbitrary length, because 2, you can think of it like binary, almost like a 0 and 1, where 0 is plus and 1 is a star. We're going to go through and come up with all the possible ways of doing this. Let me think real quick. I don't think there's a way to iteratively do this. I think we might have to reach for recursion for this. I might be putting the cart before the horse here. This might be my computer science background kicking in and wanting to use recursion, but I think we're going to have to use recursion because I've done similar things as like when programming a calculator. This was a million years ago for my university, but programming a calculator, I remember we had to do something like this. So we'll see if that's what has to happen here. There is a way for iterative. Okay, cool. Yeah, I'm willing to bet there is. It's one of those things where there probably is, but my brain just reaches for recursion first. And it's probably not great that I do, but like that's just, I'm more comfortable with that. And then when it comes to an iterative solution, I have to manually unwind what I've done. So what we need to do is we need to take these numbers and do some sort of operation to them. These numbers take some sort of operation to them. What I'm thinking is for the first set, we'll come up with a string that's either plus or star. For this set down here, we'll come up with a string that looks like this. We need 3 operators. It'll be like plus plus plus, plus plus star, plus star plus, plus star star. We're counting up in binary. That's all we're effectively doing. But I shouldn't say binary. We're counting up in a base that is equivalent to the number of operators that we have, which is 2, and to the length of whatever the number of numbers is here minus 1. So we have good mathematical ways of describing what we're seeing. That might be confusing. I can break it down in code. Let's jump in. Part 1. User bin env bash. Okay. Let's see. First thing we should do, of course, read in our data. Let's think about how we want to do this. Pretty much all our examples start with that exact same code. We just read the data in, I'll show you. We read the data in line by line, and we just print the line. There is no trickery here, nothing fancy. So we can just do part 1, read in from example. I didn't put the dot slash. And all we'll do is it'll give us the exact same thing that's in there, and it will print it out to us. Technically, it's not the exact same thing. It might chop off some leading and trailing spaces, but we can deal with that later. Depends on so many things. Whatever, I'm derailing. Let's not even talk about what it depends on. Let's do this. So we have the colon first, and then we have the number separated by spaces. So let's separate based on colons first. IFS equals colon. Let's read the, what do they call these values? I'm going to go pull up the actual puzzle, and we're going to look at what they've called these numbers. The test value appears before the colon, so test value. And then the other one would be numbers. Test value in numbers is what we're going to call them. I've learned that I'm bad at naming things, so I'm just going to go with what they have. Test number, and I said values, numbers. Cool. So now we will echo test number is numbers. And if we did this right, our output should look slightly different and show that we are parsing it. Look at that. As you can see, there's an extra space here. That's okay, because we're going to filter that out because we're going to break these into an array. And that's what we're going to do next. All right, so now that we have test number as numbers, we need to break numbers into, let's overwrite the variable. We'll just use the same name. I think this is valid. I think you can do this. What I'm doing here is we're going to read -r so we don't do any backslash mangling. -a means into an indexed array. This is the name of the variable we'll save it to. We're going to overwrite this variable numbers. So we're going to read that string of all the numbers into an array of all that numbers, all those numbers. So what we can say is test number is, and then we can put this. Now we can printf. Let's do space %d new line. And then we can do array syntax notation to break the array into all its constituent parts. And then we should get some nice output here. Cool. This is a lot nicer output. What that means is 190 has these two numbers in it. This has these three numbers in it. Those two leading spaces I put there. They're not stored in the array. So we are breaking this apart nicely. So what do we do now? We have a test number and we have all of the numbers that we need to test. Okay, so now that we have all the numbers, the number of operators we need, num oppers, is the number, God, this is confusing, that's called number. So how many numbers we have for this test, we're gonna get the length of it, and then we're gonna subtract 1. So if there's 5 numbers, we need 4 operators. You know, like if there's 2 numbers, like 2, 2, we need 1 operator, 2 plus 2, 2 times 2. So let's do this. Echo test number needs num oppers. So we can see, oh, -1 for every single one. Cool, what did I do wrong here? I used the wrong variable name. Cool. So the test value of 190 needs 1 operator. The test value of 161011 needs 2 operators. So that means there'd be 3 numbers in this one, but we need 2 operators. So we have to go through and generate all possible operators for this test. So generate all possible operators for this test. Now I think we're going to use a function. Let's just imagine what it would look like. It would be like generate operators, and it would return like, I don't know, some new line separated list of all possible operators, something like that. We'll deal with it as we deal with it. And we'll give it the num operators. What we also need is a list of all possible operators. So here are all the possible operators we can have, plus and star. If you've never seen this in Bash, opening and closing paren is how we make an indexed array. This would be like, square brackets in most other languages. And these are just 2 strings. You separate them by spaces. So yeah. So we have plus and we have star. So this is how many operators there are. Now we have to generate all the operators for num oppers. So let's go ahead and define that here. So now we know how many operators to generate for. So let me think about how we do this. If we know we have to generate a string for 5 operators, a string of length 5 basically, for all possible arrangements, we're going to need 2 to the 5. So what's that, 32? And when I say 2, it's because that's the number of operators. So we're going to need 32 possibilities. How do we get that number? I think we have to start the string somehow. So I think the way we do it, let's make a new... I think we have to loop over each operator. Let's loop over each operator. Opper in operators. Do done. Okay. So this will be plus and then star. I think what we're going to do here... I think we make a new string here. I think we add the operator to it. We'll clean up this code later. I'm working through my brain right now. We add the operator to the string, and then we do something else. Let me just echo opper real quick and just see what we actually have right now. This needs 3 operators, and it printed out plus. And then it printed out example input.txt, then it printed out part 1. What's being interpreted? What is being interpreted? Oh my god. Oh my god. This is so funny. Oh my god. It's plus and star, so these are being interpreted as globs on the system, so it's actually reading files from the system because I didn't quote this expansion. Kids, quote all your expansions. Kids, quote all of your expansions. Or I'm lying to you. What am I doing wrong here? Is it this? What am I doing wrong? Oh, no. I was wrong. I'm right, but I was wrong. I was wrong with the actual way this is happening. It's here. This star is being expanded. I'm just going to go ahead and quote all these. That star is being expanded to all files in my current directory. That's so stupid. There we go. So now we've generated a string that starts with plus, and we've generated a string that starts with star. So we're off to a good start. That is how the two strings should start. So this one starts with a star, and then we need to call this again. What do we need to do here? Let me think about this. Because my brain is thinking recursively. I'm thinking generate operators is going to have to call generate operators again until it's called with 0. Oh boy. Okay. I know what has to happen here. We need num operators, but we also need the base string. We need to keep the prefix. We'll call it prefix. So we'll keep a prefix here, and we'll do num operators as 2. This one starts it, so there is no prefix. We're just going to give it a blank string. And then we're going to call ourselves here. Yeah, so for each operator in this, we're going to make a copy of the prefix. So we're going to copy this string. We're going to add the new operator to the copy. And then we're going to call generate operators with that new copy of it and one less num oppers. So -1. I think that's it. And then we just need a trigger here to figure out when we're done. If num oppers equals 0, I think, then we're done. What do we do when we're done? Just return? I guess that gets us out of this loop, right? Oh, and if we're done, then we need to echo the prefix because that's the final string that we have built. I think this is going to work. Oh my god. Yeah. Okay. Perfect. Beautiful. Beautiful. So for a string of length 1, we have plus and star. For a string of length 2, we have these 4 combinations. If I were to replace the plus with, 0 and the star with 1, it would just look like we're counting up in binary. Let's do that. TR plus with 0, plus star, 0, 1. There we go. Look at that. If we just replace them, it looks like we're counting up in binary. So that's perfect. And this handles an arbitrarily large number of operators. Cool. So now that we have that string, we can do while read-ra operators do done, and then we'll read this in through process substitution. Let me just print this out and make sure everything's how we expect it to be. I think that's how we expect it to be. Yeah. So now we have an array of all the operators. So what we have to do is we have to do work. We have to go actually do math now. Yeah. Cool. Let's go through this now. We have numbers and operators. So we should have one more number than we have operator. So what we need to do is we need to step through these and do the math. We have all the operators and all the numbers. So we'll index over both of them at the same time. I less than. Which one's higher? Numbers ling, right? Yeah. Okay. We have one set of numbers operator tests. Okay, so we're going to go through the first thing to test. And the way we're going to test it is by creating an accumulator here of 0. And then we'll go ahead and grab the first number and the first operation, right? No. No, 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 no. I know what we want to do. Grab the first operator, and we'll start with the accumulator. Yeah, we'll have to grab the number before it. Previous number will set equal to numbers 0. This will be the first number. And then here, we will grab the operator, which is operator at spot 0, or spot I, which could be 0 in this case. And then the number that we're going to act on, current number, is the numbers at spot I plus 1, because numbers will always be 1 higher than operators. So now we have this. We have prev and we have current. Okay. Yeah. So what we need to do is we need to do what the operator says. So case oper in. If the operator is a star, then we need to multiply them together. Oh, and we should store it as previous. I guess this is what the accumulator is going to be. But let's do this for now. If yeah, let me think about how to do this. Prev times equal cur. If it's a plus, then prev plus equal cur. And if it's anything else, then that shouldn't happen. So let's just go ahead and put like an exit 5 here. ESAC. Okay. So now we're kind of using previous as our accumulator. Okay. Yeah, we're overwriting previous with whatever the operation is of the current number. This is going to have a lot, but let's go ahead and just generate what this looks like. Or it's going to exit 5. No, it's going to exit 0. All right, well, I'm doing something wrong here. Yes, I am. Operator is not being indexed as an array. That's exactly what I'm doing wrong. Let's see. So we are still doing things wrong. What are we doing wrong? Something's dying when we're in here. Why are we dying when we are in here? How? How are we dying when we're in here without echoing prev? And without exiting 5? Okay. We're stuck reading somewhere. Where do I do a read command and not actually read data in? Yeah, this should read... This should be fine, right? Oh, wait, am I just... Is it just this? Is that the problem? What am I doing wrong here? I'm missing something very obvious. Okay, now we got an exit 5 on that one. Okay, cool. So... what do we print here? Got a blank operator? How do we get a blank operator? Let's print all our operators. Let's stop doing bash minus x. That's a lot of output to keep up with. Yeah, okay, we only had one operator and it was a plus sign. Is there something weird about this? Yeah, somehow the operator is blank. Why is the operator blank here? Oh, probably because I'm using operator here and not operators. How many times am I going to make this mistake? How many times am I going to hit this mistake? Okay, well, we're getting something better now. Now we have an operator of plus plus, so that's clearly wrong. I'll take a break. Let's look at chat. Could this be done using PypeBC? Probably. I just prefer to use Bash as internal mathematics. You haven't hit this yet, but I'm curious how you troubleshoot an issue where the example data works and the input data doesn't work. I've encountered that once. That was yesterday when I did day 6, when I redid it in Rust. That was stupid because you had to figure out the place. There was like this guard and you need to figure out all the places she went to. And I wasn't counting the initial spot that she was in. In the example data, she makes a loop over the initial spot. In my real data, she never went back to the initial spot. So example data worked, real data failed. That was super annoying. That was one of those things where I was like, wait, how am I going to do this? When each iteration takes 20 minutes, it's hard to find the problems. Yeah, I agree with that. 100%. Oh my God. You have to do your best to try and exit early, exit fast. That's the only advice I can give you for that. Day 6, part 2, Rust coming when? I should work on that whenever I have time. Maybe at the end of the stream. We'll see how things are going. I think it'd be fun to do that and then compare timing, you know. Yeah. But let's knock out part 1 and part 2 of these today. So for operators, it's not being saved as an array. Oh, and of course it's not. Of course it's not. Because I'm just separating them based on... I'm just shoving them all together. I'm not putting spaces between them. So let's go ahead and add oper space here. There we go. There we go. Okay. So let's get rid of all these little debugging things that I've added. And let's go ahead and check this. So now we have prev. We're going to change prev to accumulator. I think this more accurately describes what it is. And then we will say if accum equals test number, then we found, what do they call them? Safe or something? What was the word they use? We found a satisfied result. We found a true result, I guess we'll call it. So let's call this total equals 0. And then if we found a true result, we will do a total plus equal accum. Actually, let's just do total plus equal test value. Echo made test number true with operators. Cool. And then all the way at the bottom, we can just echo final total equals total. Oh, where do I put the needs? That's annoying. All right. Okay. Made 190 true with star. Made this one true with plus star. Made this true, made this true. So the final total is 71.6. That doesn't seem right. Let's pull this back up. So we made 190 true. We made 3267 true. Oh, yeah, I see what's happening already. 190, 3267, and 292. We did make those true, but look at what we also did. We made 3267 true twice. We need to break out once we made it true the first time. And this fix is going to be super easy because once we found this one that's right, we can just break. There we go. Okay, so our total there is 3749. We should have 3749. Hey, look at that. So you know what that means? We're going to do the thing that Matthew hates. We're going to use the real input now and get the right answer. Oh, I didn't think everything would just print to the screen. Oh, this is kind of cool to watch it. It's kind of neat. I wonder how long the solution will actually take. Like, that's not that bad. That number's huge. That number is absolutely huge. Is that going to be valid? Okay. That's the right answer. You are 1 gold star closer to finding the chief historian. We are on a streak. Day 7, part 1. Still have not submitted a bad answer. We have only submitted correct answers. Let's go. Let's go. Let's go. Oh my god, that's awesome. On to part 2. What do you say? The engineers seem concerned. The total calibration result you gave them is nowhere close to being within safety tolerances. Just then, you spot your mistake. Some well-hidden elephants are holding a third type of operator. We prepared for this. We prepared for this. The concatenation operator, double pipe. We did not prepare for the operator being multiple characters. We did not prepare for the operator being multiple characters. I think it'll be fine. The double pipe combines the digits from its left and right inputs into a single number. For example, 1, 2, 3, 4 would become 1, 2, 3, 4. All operators are still evaluated left to right. Yes, Bash treats numbers like strings. Oh my god, we might be so good here. Now, apart from the 3 equations that could be made truly using addition and multiplication, the above example has 3 more equations that can be made true by inserting the operators. Adding up all 6 test values, the 3 that could be made before using only plus and star, plus the new 3 that can be made using the pipe. This is gonna be so easy. I'm not lying. This is gonna be so easy. Like 5 minutes. 5 minutes. Oh my god. Let's just do this. Oh my god. I am so stoked. It never works out like this. I am prepared for this. This is like a first. This is a first. Okay. Part 2. We're gonna add an operator. The operator that we're adding is pipe. Cool. And now if the operator, which I think we always pass properly, yeah, I think we're okay here. We're going to add the pipe operator. And if the pipe operator is given, we will do a cum equals a cum next to cur, because we just concatenate them. I think this addition of one line and this modification of another line, I think that's it. I literally think that's it. So according to the screen over here, let's take a look. The new calibration result should be 11387. I said it was going to be easy. I said it was going to be easy. Oh my god. Because we did the hard work up front. Because we allowed for an arbitrarily large list of operators. This is going to be easy. Oh my god. I'm going to filter out all of the echoing of the test thing. So we're not going to get flooded with output. So let's go through and run this. And let's put a time in front of it. And that's it. That's it. That's it. Oh, right. Let's do the real input and we're going to time it. So I think this took, what did it take? Like 10 seconds, 15 seconds. So it's going to take longer. It's going to take exponentially longer, right? Yeah. I might put a progress thing in it if it takes too long, but we will see how long this takes. The beauty of this is, if it takes too long, this is something that can be parallelized because none of the tests rely on the test before or after it. So if we do need to parallelize this, we can. Because I have no indication of how long this thing is going to take. I say we let it run for like a minute. And if it takes, longer than that, then we figure out a way to deal with it. But, God, I'm scared to see how big this number can be, too. Like, because that last number was big. Are we bumping against, 64-bit limits? Probably not. Wow. This should just work. Very slowly, apparently. But it should just work. Oh, man. Yeah, well, the debugs would tell me what's going on. I purposely took those out. I didn't want to, print out the puzzle as I was doing it. But yeah. I'd be curious to see, what the line count is of the real input and what line we're currently processing. Even that would be useful for getting an idea of how long it took. Because right now, yeah, we have no insight. It could be 5 seconds away from finishing. It could be 5 minutes away from finishing. Yeah, this sucks. I can't believe it's making it take this much longer. It makes sense that it would be, but wow. All right. I think I'm going to call it. I'm going to stop it. And we're going to add some debug output to it. Oh, yeah, that was already running for 2 minutes. Let's see. The real input is only 850 lines. Oh, boy. Okay. So we'll do a nice little printf line. Let's say, iter equals 0. Iter plus plus printf testing iter the number r let's get an idea of how fast this was going. Okay. It only has to get to 850, right? Oh boy. So what are our options here? We could parallelize it and have them all write out to like individual files or something. And then we could read in those files like, yeah, that'd probably be the way to do it. What we could do, I'm thinking. So we do just have to wait for that to get to 850 before we get the answer. Do we want to try and parallelize it right now? I think the answer is yes, because that'd be a lot of fun, right? The problem is we need to return, what do we need to return? If it was good or not? Yeah, that's going to be tough. That's going to be actually very tough. What we're going to need to do is we're going to need to come up with an ID for all these. We're going to have to write data out to the machine. We're going to have to actually write data out, and we'll have to write out line numbers for each one. So we'll make dir -p data. What I'm going to do, I'll show you what I'm going to do. We're going to make dir called data, and inside data, it's going to have files like 1, 2, 3, 4, 5. So literally it'll have 1, and in there will be the answer to the first iteration, like what that number should be that we add to it, or it's going to be 0 if there's nothing in there. I think that's how we're going to do it. So we've gone through. Okay, so now we have one number and one thing to test. Test all operators. I think we can do this. This might require some trial and error, but I think we'll be okay. We could just let it finish, but I don't think that's fun. I think it's more fun to work on the performance of it. So we're going to make a function here called test all operators. What will we give it? We have to give it a list of the operators and a list of the numbers. How do we do that comfortably? How do we pass that data in comfortably? I think we pass... 5 minutes to run and 1 minute to solve. Dude, truly. Yeah, I don't even know if I want to do it this way. I'm thinking, I don't know. I kind of just want to let it run, right? I do kind of want to let it just run. I think I might just let it run. I know it's going to be boring, but I think that's the way to do it. So yeah, I think there's 850 that have to be tested here. Yeah. Let me add a way for it to write out its solution so we can start at the top. Let's see. So we're going to check if there's a file that exists with that name. That's where we're going to write these data out to be persistent. If that file exists, then we're going to skip it. Otherwise, we're going to do all this work, and we are going to write out the accumulator value. Yeah, we're going to write out the test number to it. Let me think about how we're going to do this. I have to think about how we're going to write this out. Yep, so if we found a true result, then we will, we'll make a variable for this. Then result equals test number break. Else result equals 0. And then when we break out of this one, we will echo the result into the file. I think that's what we're going to do. So when we run this, what's going to happen, I'll let it run for like a little tiny bit. Okay, now it's ran for a little bit. We're going to ls data, and we're going to have these files in there. So if we cat data 1, we'll see that it has a number in it. That one has a number in it. This has a large number in it. This has small numbers in it. So we'll just have to go through and add up these numbers when we're done. That's all we'll have to do. And that way we can kind of restart this. Let me go ahead and just delete that. Let's now, if we rerun it, it should start at like 10. There we go. Cool. So the nice thing is if something breaks, we at least have all of these solutions that we've done so far. I really like this solution. It's going to be ugly. It's going to take some iteration, but let's go ahead and do this solution. Let's first try to go through and find all the solutions that only use a plus. Cool. That final total might be wrong. I don't really care. Actually, we can just ls data and see. Okay, so all of those could be solved using just a plus. Let's look at all the ones that can be solved using just a star. Cool, whatever, I don't care. And then we'll check all the ones that can be solved using a plus and a star. Then we'll check all the ones that can be solved using a pipe and a star. And then we'll check all the ones that can be solved using a pipe and a plus. And then we'll go through and solve all the ones that can be solved using all three. Is that it? That can't be it, right? This is one of those things where I'm not certain of this. If I add all these up, how will this work? So if we cat data, we'll have all of this stuff that we need to go through and add up. Is there an easy way to just add up this? I think I can just use awk, right? Can you just do like, I don't know, n plus equal $1, and then end print n? Is that valid, awk? Guys, I am not certain about this, but we're going to test it. This could be my first one that fails. Let's go ahead and try this. We have our first failure. That's not the right answer. Your answer is too low. If you're stuck, make sure you're using the full input data. There are also some general tips in the About page. That's great. Oh, we have our first wrong answer. The streak ends here, and I was so confident. I do bet if I let that one solution just go, it would be done, but oh man, brutal. All right, let's RM everything in data. Let's try this again. Yeah, let's solve all the ones that can be solved just using a plus. That's not what I wanted. Let's not even bother timing it. There's no reason to do this. Okay, so we were going through... Oh, thank you. Yeah. This is all I'm doing. I'm just going through. I've edited the source code, so we are just looking at those that can be solved using a plus. I don't like that it prints final total 0. That's not really useful. So let's instead do this. Echo puzzle iter solved. Yeah, so let's go ahead and do that. Let's rm data. Let's start over. So now if we do this, we're just going to check with the plus signs. Okay, so these are all the ones that are solved using just plus signs. Which is good, because let's get all these out early. I know what's happening. I know what's happening. I know exactly what's happening. And I know exactly why my number's too low. Because when we don't solve it, we write a 0 to the file. That's the problem. We should only be writing to the file when we have a good result. Otherwise, we shouldn't even be touching that file. That's what our problem was. That's exactly what our problem was. So let's go ahead and do this again. I should try with the sample data. I really should. I shouldn't just bother with this. But I'm stubborn now, and we're in it. So this is going to go through and solve all of them with just pluses. So if we do an ls data pipe word count -l, we can see that we have 299 solutions. Cool. Let's go ahead and... Oh, wait. Did we actually do plus and stars? Oh, okay. Plus and pipes. Let's go ahead and do that. And then we'll do pipe and stars is the last one that needs to be done. Pipe and stars. Okay. This is not painfully slow. Pipe and stars. It is funny to see how if you don't optimize early, it comes to bite you when you have really big input data. All right, plus. This is the part that could take a while. Actually, before I do that, what are we dealing with? Out of the 850, we only have 339. All right, so this might take a bit. This is the one that could take a little bit longer. We're not going to have 850 solutions total, right? There are going to be some that just do not get solved, and that's totally fine. So this is going to go through the final ones and solve them. So yeah, this could take a bit. I'm going to let this run. I'm going to go grab another drink real quick. So we'll just let this run, and we'll see what happens. I think that's what we're going to do. We're going to allow this thing to take arguments. And the arguments will be... What should the arguments be? Let's see. Max is 50. Let me think. We'll go up to 50. And we'll start at $1. The user will give us a number to start at. So, that's what we'll do. Start and max. If, let's see, iter is less than start, we continue. That should be and. So we're going to take an argument. We're only going to let this program do a couple of them. If it's greater than... I'll make sure I get this logic right. So we'll give it 0. It'll go up 50. So if it's less than 0, we don't care about it. And if it's greater than 50, we want to continue, but we will actually do 50. Yeah, we'll do greater than equal. Okay, so now I think if we did this right, we can give it puzzles. Let's say it'll start at 200, or it'll have a syntax error. Oh yeah, that makes sense. Gotta put a $sign here. We'll start at 200. So it'll start at 200 and work its way up to 250. That's what it will do. The reason this is important is because now we can do this. For I in 0, ... let's say 900, just higher than what we have. Count up by 50s. I'll echo this so we'll actually see what gets run. We'll echo part2 $I done. Okay, this might be confusing, but I'll show you what will happen. I'm going to put a do here. Do echo. This is what's going to get run. It's going to go through and run all these. So they'll start at those numbers. So we're going to have concurrency of about 19 at a time. A little bit less because I don't think it goes above 850. So we're going to do 19 at a time. They're all going to go up to 50. And we're going to put them in the background. You ready for this? So now we have a concurrency of 19. So 19 workers are going, and they only need to test 50 things. And some of those 50 are already done. So this should be 19 times faster. We're letting the system with fork and exec handle parallelization for us. This is scuffed, guys. But I love it. Oh, this is worse than threads. This is worse than threads. Threads your operating system can support, and a single process can make multiple threads. We're making new processes. We are forking, we are execing, we are doing heavyweight stuff here. We are in the 90s here. I even think the threading was before that, so we're old school. Corruption of data files. Yeah, that's why we have to make sure they are not writing to the same file. That is why they only write to their own IDs. They're reading from the same file. That's fine. Unix can handle multiple readers, but we're not ever writing to the same file. So as long as we keep those constraints fine, we'll be okay. Look at them. They're all getting up there. I think we're going to be done soon. Oh, wow. Look at that. A lot of those are done. If we run jobs, there are still 4 or 5 running. Okay, so there are still 5 outstanding. Done. Okay, we have 1 left. 1 left. That's not right. That is not the iteration it's testing. It's got to be concatenation of multiple things of output. Okay, done. We have no more outstanding jobs. So let's ls data. So of those like 850, 455 of them were good. So now we are going to total them all up. And this is how I total them all up. I concatenated, every file and summed them. And now we get this number. Now we will go over here. We will test this number. Thank you. Fork and exec. That's the right answer. You are 1 gold star closer to finding the chief historian. We have completed day 7. Yo, that was wild. I hope we never have to do that again. We're going to have to do this, guaranteed. But man, that was awesome. How much fun was that? Oh man, that was great. Woohoo, GG indeed. Oh my God.